happens if we want to find the probability of z greater than 0.86? Okay, so draw a distribution. Say 0.86 is here. Greater than 0.86 is up there in the tail. And note that the z distribution goes out to plus infinity on the positive side and negative infinity on the negative side. Well, this is an area that we cannot find from the tables. We can find the area from 0 to 0.86 from the table, so we know what that is, whatever, right, from previous page, 0.3051. So what's this value over here? Well, this whole side of the distribution is a half, right? So 0.3051 plus something is going to equal a half. So whatever, this is going to be a half minus 3051, so that the two of them added up together is equal to a half. Alright, so this is not exactly a complement, but it's similar in concept. And whatever that will be, 1949 or something. Okay, and so we can find areas in the tail like that. So similarly, the probability of getting a z value less than negative 0.86 this tail here is identical to the tail we just found, right? These two are equal. So whatever this is, and we already know that from the above example, that's 0.1949, or the half minus the 0.3051. Alright, so we know now how to find probabilities from 0 to some value, be it positive or negative, right, from the middle of the distribution to some value. And we also know how to find the area in the tails. Remember that area and probability are synonymous here. Okay, alright. Of course, we can need to do sometimes some more difficult probabilities. Let's say we want to find the probability of getting between 0.94 and 2.39. Okay, well, draw a distribution and figure out what the area might look like. Let's say 0.94 is there and 2.39 is here, and so the area, the probability that we're looking for, is between those two values. Alright, how do we do that? Well, you just do it the best you can, right? So we can find from our tables the area from here to here. Okay, we can also find from our tables the area from 0 to 0.94. Of course, the area from 0 to 0.239 is larger, and it's too much, so first let's get that. Alright, so that's, as I said, too big. How much is it too big? Well, the area from 0 to 0.94 needs to be subtracted from that. Alright, and both those values can be found from the tables. If you're comfortable with the table already, go look at the tables yourself, pause the video, and find the numbers and work that out. But I'll continue right now. Alright, so from 0 to 2.39, it's going to be hard to read, 2.39. Alright, 0.9 is that last column there. I have to make it look like this, obliterate the top so I can so that you can see it on the screen. That's 0.4916 minus the area, the probability from 0 to 0.94. Alright, 0.94. That value there, 3264. And my calculations show that that's 0.16 2. Okay, and so we could do the same thing on the other side of the distribution. Let's say we're looking for an area from 3.06 down to 1.38. Sorry, negative. Right, both on the negative side on our z distribution. So this is the 0 point, say, negative 3.06 here, negative 1.38 there. We're looking for the probability between those, alright, the area between them. So we do the same thing as before. We take the larger area, alright, from, in this case, negative 306 to 0, and then we're going to subtract out the area from 0 to 1.38, or 1.38 to 0. Okay. Alright, again we'll look up our tables. 3.06, 3.0 is the last line of the table. 3.0, 1, 2, 3, 4, 5, 6. Is that value 4989? Oops, 89. Minus the area from 0 to 1.38. Alright, 1.38. That value there, 0.4162. Okay, my calculations show that that's 0.827. Alright, so again we can see that something on the negative side is just analogous to something on the positive side. Alright, what else? What other type of probabilities could we have? Well, we could straddle the mean. We could go from negative 2.58 to positive 0.57. Again, draw the diagram. You do it for yourself, not for me. It's very useful though to get a handle on the area, not perhaps so much for the standard normal after a while, but for a generic normal, as we'd see later. So what we have is an area that goes from one side of the mean to another. So we're going to get this area from our tables, call it T1, this area from our tables T2, and of course since it crosses we're going to have to add those two areas together. So that's simple enough. So we go from minus 2.58 to 0, a value from the table, and then we're going to add from 0 to positive 0.57, another value from the table. Alright, so 2.58, 2.58 is over here, 4951 plus, and then from 0 to 57, 57 is there. That's 2157. Alright, and I get that that's 0.7108. Okay. Alright, what I want you to do now is to do these probabilities yourself from the z distribution. They follow a lot of the stuff that we've done right now. Before you go ahead and do it, let me point out that if you needed to find the probability of getting between 0 and some number, say not on the chart, right? The chart stops at 3.09. We'll say that that's approximately a half. Okay. Beyond that, you have that in your intelligence, of course, should enable you to do all of these problems. Alright, so if I was you, I would copy these down, pause the video, and try them, and then continue the video to see the answers.